All right, today we're diving deep, and I mean deep, inside the brain. We're on a mission to map a truly mysterious, crescent-shaped region that has had scientists scratching their heads for decades. Let's get into it.
So let me start by asking you a question. What single part of your brain do you think is handling your emotions, your ability to move, and your sense of where you are in the world, all at the same time? I mean, that sounds like it should be three completely different parts of the brain, right?
Well, believe it or not, the answer is this amazing structure right here, the cingulate cortex. It's this beautiful crescent shape, and it's tucked away deep, deep in the middle of your brain. For the longest time, what it actually does has been a huge scientific puzzle.
So how in the world do you solve a mystery like that? How do you map a part of the brain that's so hard to get to? Well, the answer is pretty incredible. You probe it, very carefully, with tiny pulses of electricity.
Now this is where things get really clever. The researchers had this rare, perfect opportunity. They could work with patients who were already being treated for severe epilepsy. This created what you might call a natural experiment, giving them a safe, ethical, and direct window into the living, thinking human brain.
The technique is called electrical cortical stimulation, or ECS. So here's how it works. As part of their treatment, these patients already have tiny electrodes placed safely in their brain. The researchers can then send a very small, totally safe electrical pulse to one specific point. And here's the amazing part. The patient is wide awake, and they can tell the researchers exactly what they're feeling or seeing in that moment. Every single report is like putting a new pin on a map, slowly building a picture of what each tiny spot does.
And get this, we're not talking about a couple of people. They gathered data from 124 different patients. That created this incredibly rich, detailed map with over 800 different points of stimulation. So what did they find?
Well, check this out. While a lot of the zaps didn't cause any noticeable response, a huge number, 329 of them, did. They triggered a specific feeling, an emotion, a movement. And this is where the real detective work begins. What were those responses, and where exactly were they coming from?
So this brings us to a kind of grand tour of the cingulate cortex. We're going to travel through it piece by piece to see what functions are hiding where.
Our first stop is right up front, at the head of that crescent shape we saw. This is the anterior cingulate cortex, or let's just call it the ACC.
And this map just reveals something so cool. When they stimulated the ACC, the responses were almost all what we'd call affective, related to emotion, and autonomic, which are your body's automatic functions, like your heart beating faster.
And these weren't just vague feelings. Patients described really specific things. A sudden wave of fear, an uncontrollable smile, a racing heart, a tightness in their chest. Even the bizarre sensation of feeling blood rushing up through their body.
Okay, so the front is all about emotion. Now let's slide back a little further on our tour. We're now in the middle section, the middle cingulate cortex, or MCC.
And whoa! Talk about a change of scenery. This part is a completely different world. Look at all those yellow dots. This map makes it super clear. The MCC is a major hub for motor responses. It's all about movement.
And the things people experienced here are just wild. Stimulating this area made their arms or legs lift or twist all on their own. Some people felt this intense urge to move a limb, even if it didn't actually move at all. Others started shaking, or even felt like they couldn't speak, as if their mouth was being controlled by something else.
All right, one last stop on our tour. We're heading all the way to the back of the crescent now, to an area called the posterior cingulate cortex, or PCC.
And yep, you guessed it, the function shifts dramatically again. These maps show that the PCC is all about your senses. Specifically, it's processing what you see, your visual system, and your sense of balance and place in the world, which is your vestibular system.
So stimulating this area caused things like blurred vision, or seeing flashes of bright light. But it also triggered intense dizziness, vertigo, and even trance-like states. People reported these really bizarre feelings, like their whole body was shaking or that they were suddenly weightless.
So let's pause. We found separate homes for emotion, for movement, and for our senses. But this is where the study makes its biggest, most important discovery. Uncovering the one place where all these different functions finally come together.
Think of it like a puzzle. On one hand, you have all these different pieces, sensations, motor commands, what you're seeing, your sense of balance. They all seem totally separate. But what the researchers found is that they all connect. They all converge in one tiny critical spot.
And that spot has a name, the Cingulate Sulcus Visual Area, or CSV for short.
It's this newly mapped area, sitting right at the junction, the crossroads between that motor region and the vision and balance region. And its job? It seems to be the master coordinator for all of it.
I mean, the study's conclusion puts it perfectly. This is a direct quote. The CSV is an integrating node of sensory, motor, vestibular, and visual systems. It's the place where all those different streams of information get woven together into a single, coherent experience.
Okay, so we've finished our tour, we found this incredible integration hub, but let's step back for a second and ask the big question. Why does any of this actually matter? What's the big deal about this new map? Well, this table just sums it all up so nicely. You have emotion in the front with the ACC. You have movement in the middle with the MCC. You have vision and balance in the back with the PCC. And then right at that crucial junction, you have the CSV, the conductor of the orchestra, putting it all together. It's such an elegant and organized system for managing our most complex experiences.
And this leaves us with a final, pretty mind-blowing thought. If this one small area of the brain is so critical for weaving together our senses, our actions, and our place in the world, for basically creating our reality, what happens when it gets disrupted by an injury or disease? This map doesn't just tell us where things are. It gives us a profound new way to think about consciousness itself.